Hi, welcome to my video on part 3, which is on solving cubic inequalities. Number 1, let's solve this cubic inequality. How do I know it's cubic? Because I have x squared times x gives me x cubed, so it's a cubic inequality. It's an inequality because I have a less than. So, to simplify this, I obey PEMDAS. I remove the brackets, so x squared times x is x cubed. X squared times plus 2 is plus 2x squared. X times negative x times x is negative x squared. Negative x times 6 is a negative 6x is less than or equal to 0. So we have to simplify by adding like terms. So 2x squared subtract 1x squared is x squared minus 6x less than or equal to 0. Notice we have a cubic. We have 3 possible answers. So I look through and I see x is a GCF, so I'll remove the x. So x cubed divided by x is x squared. X squared divided by x is x. And negative 6x divided by x is negative 6. So we have a x, and we have a quadratic here. Let's see if it's factorable. X squared is x times x. Factors of 6 are 1 times 6 and 3 times 2. What pair of factors give me a 1? It's 3 and 2. And the product is negative 6, and the sum is plus 1. So it has to be positive 3, negative 2. Multiply, negative 6, add 3 and negative 2, 1. So we have x is equal to 0. We have x plus 3 is equal to 0. X minus 2 is equal to 0. So x is negative 3. X is 2. So these are 3 integers on the number line. So the integers, x is negative 3, a 0, and a 2. Not worried about the exact location, but as long as they're in the right order. So what we have is we have to find out the interval. This is like a cubic graph, which is a cubic graph swings like this, or it could go up here, down, through, and swing like that. We're looking for the values of x, which is this. Notice that this says less than, and less than we're looking for negative. So let's take the number 3. In between 0 and 2 is a 1. In between 0 and negative 3 is, let's take a negative 1. And to the left is negative 4. So let's take the 3 and plug it into this factored form here. We plug a 3 here, we get positive. 3 here is a positive. 3 here is a positive. So we get a positive times a positive times a positive. So we have a positive. Let's put a 1 in. We're looking at the signs, not at the numbers. Put a 1 in. 1 is positive. 1 is positive. And a 1 is negative. So we have a positive, positive, negative. Product is negative. Put a negative 1 in. Negative 1 is negative. Negative 1 here is positive. Negative 1 here is negative. So we have a negative, positive, negative. Product is positive. And we sub in the negative 4. For the negative 4 here, we get a negative. Negative 4 here, we get a negative. Negative 4 here, we get a negative. So it's a negative, negative, negative. Product is negative. So the solution has to be less than. Less than is a negative. So we're looking at, notice we got equal to. So it says equal to, so we're allowed to have the 0. We're allowed to have the negative 3 because it's equal to. And we're allowed to have the 2, so that's solid dots indicating that they're passing through. Or if you did the graph would be passing through these intercepts. So they're equal to, solid. And less than is a negative, so it's not here. So the negative is between these two. And the negative is to the left of the negative 3. So we look at that. So there we are. So if we take this one, that's x is less than or equal to negative 3. we take this one. 0 is less than or equal to x is less than or equal to 2. And this is an or a union. It's here or here. So that's the solution. So we can name this one. That's equal to, so square bar, -3, going to negative infinity, open. Or this is equal to, so the square bar, 0, comma, equal to square bar and 2. So that's the solutions. These are any number between 0 and 2, including 0 and 2, will make this inequality true. Any number less equal to -3 and less than -3 will make this inequality true. Okay, let's try another one. This time, to do more math, we have fractions, but the fractions have rational or algebraic expressions in the denominator. So this denominator is x plus 1. This denominator is x. So we factor this. We have x is common, and we divide x squared by x, we get x. Divide x by x, we get 1. So the LCD is x times x plus 1. So this denominator, x plus 1, is in here. X is right there. And x times x plus 1 is itself. So that's the LCD. And we also got to remember that x plus 1 equals 0. X is -1. That means we cannot have x to be -1 because it makes the denominator 0. X is equal to 0, so we can't have x equal to 0 because this denominator becomes 0. So we cannot have -1 and 0. So we have fractions. We multiply by the LCD. So x times x plus 1. This fraction. X times x plus 1 with this fraction. And this fraction is multiplied by x times x plus 1. If I multiply by the LCD, every denominator should cancel. So x plus 1 cancels. So I have an x times x squared minus x minus 3. The x cancels, so I have a negative of x plus 1 times x minus 1. And the x times x plus 1 is there. They cancel, so I get 6x minus 17. Now, in PEMDAS, I have to do the multiplication before the subtraction. So I multiply x times this trinomial to give me x cubed minus x squared minus 3x. Subtract, and I multiply these two, and x times x is x squared, x times -1, and 1 times x, negative x, positive x, 0. 1 times -1 is 1. That looks like the difference of 2 squares, x squared minus 1, greater than 6x minus 17. Now I do subtraction. So I can go x cubed minus x squared minus 3x. When I subtract this binomial, I add on the opposite, negative x squared plus x. Or I can put a 1 here. When I multiply 1 by this trinomial, I will get this trinomial, same. When I put a 1 here, I get a -1 times this binomial, which gives me negative x squared plus x. So now I can simplify this side before I transpose, or I can group them all, bring this over. So let's go x cubed minus, add these two, minus 2x squared minus 3x plus 1 greater than 6x minus 17. And I bring this binomial over here, so I get x cubed minus 2x squared minus 3x minus 6x plus 1 plus 17 is greater than 0. Now notice I have simplified this. I have an x cubed minus 2x squared minus 9, make that a 9x plus 18 is greater than 0. I have them in descending order. And one of the rules when you have a cubic, you see if you have what's common in these two. So I have an x squared is common here. When I take the x squared out, I get an x minus 2. In these two, I see a negative, and I have a 9. So if I take the negative 9 out of these two, I get an x minus 2. So I have x minus 2 is common, so that's the binomial GCF. So now I know that works, so I can copy that down because I did it on the side in case it didn't work. Now that I have x minus 2 common, when we take it out, we get an x squared minus 9. And now we have x squared minus 2. This is different to 2 squares, factorable. X plus 3 minus 3 greater than 0. So I have x minus 2 equals 0, so x is 2. X plus 3 equals 0. X is negative 3. X minus 3 is equal to 0, so I have x is equal to 3. And notice we have greater than. Greater than is positive, so we're looking for the positives. So I have to also remember, I have these two numbers also to put on this number line. So I have a negative 3. I have a negative 1. And I have a 2, a 3, and a 0. So there's a 0, there's a 2, and there's a 3. So that's the order. Let's see if I got them all. 2, yep, negative 3, 3, negative 1, 0, they're all there. Now, I cannot have negative 1, or I can't have 0, because they give the denominator equal to 0, and you can't divide by 0. I cannot have these because that's greater than is not equal to. So all of these integers are not included, so they're all hollow dots. Now, to find out what we're going to have, let's look at a 4. Between 2 and 3, let's take 2.5. Let's take a 1. Between negative 1 and 0, we get a negative 0.5. Between negative 3 and negative 1, we take a negative 2. And to the left, I have a negative 4. So we take our time. We got this trinomial here that we're going to sub the 4 in. Sub the 4 in, we have positive, positive, positive. So 4 gives me plus, plus, plus. So the product is positive. 2.5. 2.5 here is positive. 2.5 is positive. 2.5 is negative. So we got a positive, positive, negative. Product is negative. Let's try 1. A 1 here is negative. A 1 is positive. 1 is negative. So we got a negative, positive, negative. Product is positive. Negative 0.5. Negative 0.5 is negative, positive, and negative. So it's a negative, positive, negative. Product is positive. We got a negative 2. Negative, positive, negative. Negative, positive, negative. Product is positive. And we have negative 4. Negative 4 is negative, negative, negative. Negative, negative, negative. Product is negative. So we're looking for the positives. So because it's greater than 0. Greater than 0 is positive. So the positives are here. I'm just going to shade them in like that. Positives are here. Positives are here. And the positives are there. So these, anywhere in this shading, will satisfy this inequality. So this one here is notice it's negative 3 less than x less than negative 1. Or we got this one here. Negative 1 less than or equal to x less than or equal to 0. We have this one here. We got 0 less than x less than 2. And we have this one. Or we got x is greater than 3. Notice there's no equal signs. So these are the values of x that make this, any value of x that fits in these right here will make this true. Another way to state that is open, -3, comma, -1. Open, -1, comma, 0, open. Open. Notice there's no equal sign, so it's an open bar, no square bars here. And it's 0, comma, 2, open. And this is greater than 3, so it's open at 3 and goes to infinity. So these are the solution to this inequality. So I just wanted to review the cubics and do the solution so you can see that these inequalities are a little bit harder to do and uses a lot of math skills. And again, if you like my video, click on the like button, click on the subscribe button. If you're not a subscriber, visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. And that's the content that I have on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.